For the next topic, we have the polar coordinates and the rectangular coordinate system. So for the polar and rectangular, the relationship of them is just like this. So originally, you have here a line, this line. So of course, this point will be xy. So it will be translated, if you are dealing with a polar coordinate, it will become, instead of xy, it will become now r and theta. So using that, that is just a simple triangle, that is just a right triangle. So from that triangle, you'll get the relationship x is equal to r cosine theta, y equal to r sine theta, and r will just be the Pythagorean or the hypotenuse. So r equal to the square root of x squared plus y squared. And then theta will just be arctan of y over x. So r there will be the radius vector, what we call radius vector. It is a distance of a point in polar coordinate system from the pole or from the origin. And of course, the theta will be the vectorial angle which determines or tells you the direction of the radius vector. So we'll go to the model equation of common polar curves. So we have a circle. Okay, so circle center at 0, 0 with radius a. So r is equal to a, that will be the radius. Of course, the area will be pi a squared because r will be equal to a, and then c will just be 2 pi a. And then when the center is at x-axis and tangent to the y-axis, this will be the general equation, which is r equal to plus or minus a cosine theta. But here the d will be the diameter. So this is what it represents or looks like in a graph. And then if it is the other way around, or c or the center is at y-axis and tangent to the x-axis, this is what it looks like. And then r will be equal to plus or minus a sine theta. Of course, the diameter is still a. Next, we have the Limasson. So for the Limasson, as you can see, there will be a slight that it will be slightly different with the circle. So r will be equal to a plus or minus b cosine theta, provided that a is always greater than b. So this is what it looks like. But if it's sine, r equal to a plus or minus b sine theta, a is still greater than b, this is what it looks like. So for the area, it will just become pi over 2 times 2a squared plus b squared. Now, if a is not greater than b, instead it's the other way around, or b is greater than a, or a is less than b, there will be an inner loop. So it will look like something like this. So there will be an inner loop. Okay. Next, we have the cardioid. Okay. If from the Limasson, if a is equal to b, it will be a Limasson. So the equation will look like this. So r equal to a times 1 plus or minus cosine theta. So this will be the graph, and if it is in sine theta, this will be the graph. And the area will just be very easy, 3 over 8 pi a squared, and the perimeter will be 8a. Next is we have the lemniscate. Lemniscate is also the infinity symbol, right? So that will be r squared is equal to plus or minus a squared cosine 2 theta. Okay, so if it's plus, it is a infinity sign, and then if it's negative, it is the vertically infinity sign. So the area is just a squared. Now, if it is sine instead of cosine, it will look like something like this. This one, and then if it's positive, and if it's negative, this one. So for special cases, okay, special cases is r squared equal to a squared cosine theta, and then the area will be 2a squared. It will look something like this. Next is we have a rose. So of course, if it's a rose, it has petals. So there are two equations, other equations. We have r equal to cosine and theta, and r equal to a sine and theta. So n here will represent number of petals. So n here will be 1, 2, 3, 4, or etc. It's actually not 1, because if n is equal to 1, it will become a circle. So n represents the number of petals or leaves. So if n is odd, okay, odd is 1, 2, 1, 3, 5, etc. Not 1, actually, not 1. There are n leaves. Okay? If the n is an odd number, that will be the number of leaves, and the area will be pi over 4 a squared. But if n is even, there are 2 n leaves. Okay? And the area will be pi over 2 a squared. And this will be the example. Okay? So let me zoom in. So as you can see, if n is equal to 2, that is even, so the number of leaves will become 4 because it is times 2. But if n is equal to 3, that is an odd number, then the leaves will be 3. So as you can see here, n is equal to 4, that is even. That's why the number of leaves will be 2n or 8. So there are 8 leaves. And for n equal to 5, there will become 5 leaves because that is an odd number. So for the spiral, so a spiral, that is r equal to a theta, or a special case which is a reciprocal or hyperbolic spiral, r is equal to a over theta. So let's try some problems here. Okay. So for number 1, this is actually an easy one only. So for number 1, we have find the equivalent of the point 3, 4. You have to convert it into PCS. Okay? So you have to convert to PCS or polar coordinates. So we can have r here. Okay, r will be just be the square root of course, this is x and y. So this will be 3 squared plus 4 squared equal to 5. Right? Okay, and to get theta, that is just the arctan of y over x. Right? Y over x. So this is the arctan of 4 over 3. So theta will be equal to 53.13. This is 53.13 degrees. Okay? So this will be answer and this one. Therefore, the PCS is PCS will be 5 and 53.13 degrees. You can also represent this as 5 bar angle 53.13. Okay, this is also correct. This one and this one. So for letter B, so the circle x squared plus y squared minus 2y equal to 0. So we have to convert this into polar coordinates. Polar coordinate system. So as you can see, going back to that relation, x is equal to r cosine theta and y will be equal to r sine theta. So let's so r cosine theta, okay, that's squared plus r sine theta squared minus 2 r sine theta equal to 0. So if I will distribute the squared, you'll have your r squared cosine theta squared plus r squared sine squared theta, right? And then minus 2r sine theta equal to 0. If I will factor out the r squared, you'll left with cosine squared plus sine squared. And then transpose the 2r sine theta, so it will now become positive. And we all know that we have a identity with cosine squared theta plus sine squared theta. That will be just equal to 1, right? So you will be left with r squared times 1. I won't be writing that down anymore. So 2r sine theta. And we have r on both sides. You'll have r equal to 2 sine theta. So that is now a polar equation. That is actually a circle. Okay? So let's move on to the number 2. So for number 2, find the area of the region bounded by. So those three are actually in polar coordinates. So for letter A, you have to identify first what is that polar equation. Okay, so this graph is 2 times 1 plus cosine theta. If you go back to the equations that I discussed, this is actually a cardioid. Okay? And then this is r squared equal to 16 cosine theta. That is a lemniscate, or the infinity sign. And then for the last one, that's r equal to 4 sine 2 theta. That is a rose. So for number 1, the area for that is a equal to 3 pi over 2 a squared, where a will be this one. So if that is a, so this will become 3 pi over 2 squared. Okay, and this will be just equal to 6 pi. Right, 6 pi. So for number 2, that is a lemniscate. The area for the lemniscate is easily a equal to a squared, where a will be this one. Therefore, this is just 16. As long as you know the formulas and you memorize all the areas of formula for the areas of the polar graphs, this is actually easy. So for letter C, that's r equal to 4 sine 2 theta. Remember that the n here is this one. So n equal to 2. N equal to 2. Therefore, we can say that n is even. Therefore, there are 4 leaves. Okay. You have to multiply it by 2, the n, if it's an even number. And the area for even n, okay, for 4 leaves will be pi over 2 times a squared, right? And your a will be this one. So this will become pi over 2 times 4 squared, and this is only 8 pi. Okay, so next we have identify the curve r equal to tangent theta secant theta. Okay. So for number 3, we have r equal to tangent theta secant theta. Okay. So let's try to use some identities. So identity of tangent theta is sine theta, right? Sine theta over cosine theta. And the reciprocal of the secant theta is just 1 over cosine theta. If I will now simplify this one, I will just have here sine theta all over cosine squared theta. But remember, using the triangle of the polar relationship of polar and rectangular, okay, if this is your theta, therefore this will be your y and this is your x. Therefore, we can say that the tangent theta is just equal to, of course, this is r, right? This is y over x. Actually, we can just find sine. So, sine theta is equal to opposite over hypotenuse. Of course, this is r, right? So, this is y over r. And then, for the cosine theta, this is adjacent over hypotenuse. This is x over r. So, let's substitute those values into that. So, r now will be equal. Sine theta is 1 over r, right? And then, cosine theta is x over r squared. Right? Okay, so this will become y over r over x squared r squared. And r now will become, you can cancel out 1r. Okay, so you'll have y over x squared over r, or equal to yr over x squared. Okay, and then what you can do here is r now will become x squared here, right? Or r is equal to just write it down again, x squared, or cross multiply, you'll have a x squared equal to x squared r equal to yr and then cancel r, you'll have your x squared equal to y. So this is what you left with, but we have to identify what curve is this. So as you can see, we have only one of the x and y. X is the only one that's squared and y is in degree 1. Therefore, we can say that this is a parabola. Okay? This is a parabola which is the vertex is at 0, 0, and we have a positive, therefore this is upward. So this opens up, this opens upward. The opening is upward. Okay, so let's move on to the next topic.